How you guys doing today? We're going to help you out on learning the Rolle's theorem and mean value theorem. So we're going to start off with the Rolle's theorem here, spelled Rolle's theorem. And it says, let f be continuous on the closed interval ab and differentiable on the open interval ab. If f of a equals f of b, then there is at least one number c in a of b such that f prime of c equals 0. So we're going to put this in simpler terms for you. And we have a picture here to just kind of describe what this says. And so we can see that f of a is right here. We're going to call this point A. And so f of a is how far up it is. And then f of b, we're going to call this point B. F of b is how far up it is. So we can see that these two are equal. And so the slope would be horizontal. And a horizontal slope is 0. So all this states is that there's at least one more number in between these 2 points that the slope is also 0 at, or the tangent line. So, in simpler terms, first we have to check if the function is continuous, then we have to check if it's differentiable, and then we have to make sure f of a is equal to f of b. So we're going to start off with this one. Okay, so we have this. First we're going to see if it's continuous. It's a polynomial, so we know it's continuous. Okay, so next we need to check if it's differentiable. So we're going to take the derivative of this. It's going to be 2x minus 2. So that's also a polynomial, so it's also a differentiable. Okay, now we have to check to see if f of a is equal to f of b. So what we're going to do is we're going to plug in 0 and 2 and see if we get the same outcome. So we have 0 squared f of 0. Okay, and of course that's going to give you 0 minus 0, 0. F of 2, it's also going to give you 0. Now it doesn't matter that these are 0, you just want to make sure that these two are the same number. So that they're the same height, have the same y value on the graph, in other words. So, from here, our theorem states that f prime of c is equal to 0. So what we're going to do is, if we took the derivative here, so we're just going to bring it down, and then we're going to set it equal to 0. Okay? And now all we're going to do is find x. So, okay, we found that x equals 1. X, I just substituted in x for the value c, because it's the same thing. So, we know that at the x value 1, at the x value 1, the slope of this function is going to be 0. Okay? So, at f of 1, the slope of this is going to be 0. Okay, let's move to our second problem here. Now, first we have to check if it's continuous. This one isn't a polynomial, so it's not going to be as easy. We see that we have a denominator here. So we have to ask ourselves, what can we put into the denominator that would make it non-continuous or discontinuous? So we're going to say, well, if the denominator is equal to 0, then it will be discontinuous. So we're going to set x equal to 0. So if x is equal to 0, that would make it discontinuous. And 0 is in our interval, so this is going to be discontinuous. So then we know that Rolle's theorem does not apply. So all we're going to say is Rolle's theorem does not apply because f of x is discontinuous at f equals f of 0. Okay, so that one's done. But if we had a different interval on this, say 1 to 2, then we wouldn't care that this would be discontinuous at 0 because 0 wouldn't be inside the interval. Okay, so that's a kind of basic overview of Rolle's theorem.